Good morning. So today we're going to be taking notes on ratio tables. These notes are going to go on page 59 and 60 of your interactive notebook, so please make sure that you have gone to those pages in your interactive notebook and you put the pages on the right locations. On 60 you're going to see the page that has topic ratio tables, and on page 59 you're going to have the page that has the practice problems. We're going to go back over to page 60 and we're going to write in our essential question. Once again, the topic for these notes is ratio tables. The essential question for today, the question you should be able to answer by the time we're done, is how can I demonstrate equivalent ratios with a table? So we already know that equivalent refers to the same, and we also know that equivalent ratios are ratios that have the same value. They're just, they look slightly different. We've already worked on those things. So now it's just a different way to demonstrate that information and show how we can use the model that is a table to write these ratios. The standard that we're focusing on is 6RP, Ratios and Proportions 3. And by the end of this lesson, you should be able to make tables of equivalent ratios and plot the ordered pairs. So not only are we going to be talking about ratios, but we're going to go back to what we learned in the last unit, and we're going to talk about how we can plot those as ordered pairs. Remember, ordered pairs are those x, y values that we go over to x and then up to y. So we're going to use that kind of understanding as well on demonstrating these ratios. So let's look at now at our practice problem that we have here. Mrs. Berry needs 2 eggs for 10 pancakes. Let's make a table to show this ratio. So the first thing we always do when we have word problems is we circle the numbers and we underline the words that go with them. So let's do that. Circle 2, underline eggs. Circle 10, pancakes. So there are multiple steps in order to fill out this ratio. The first thing we're going to do is we're going to fill in the ratio we know. Okay, and looking up above here, we have 2 eggs, 10 pancakes, so that's our ratio. 2 to 10. So I've created this table over here. It has 2 columns. In the first column we have eggs, and in the second we have pancakes. And we're going to go down to where we know we have 2 eggs, we will have 10 pancakes. So this is step 1. Now step 2 is we have to find the unit rate. Remembering that unit rate is when we get it down to 1 unit. So our unit here is eggs. We know if we have 2 eggs, we get 10 pancakes. We need to get it down to how many pancakes we get if we have 1 egg. So we're going to create a proportion for that. 2 eggs, 10, I'm going to abbreviate PC for pancakes. We want to figure out 1 egg. How many pancakes? To do this, let's look at the relationship. Now, mind you, I could do cross product. I could do 10 times 1 divided by 2. Or, this one's pretty simple. I'm just going to find the proportional relationship. What do I have to do to 2 to get to 1? Christian? Divided by 2, correct. So if I do 2 divided by 2, I get 1. If I do the same thing to the pancakes, 10 divided by 2 is what, class? 5. Good. So my unit rate is going to be 1 egg for every 5 pancakes. So let's fill that in our table up here. Whoopsie daisy. So we have 1 egg, we get 5 pancakes. So now I know no matter how many eggs I have, If I multiply that times 5, I will know how many pancakes I'm going to have. If I have 100 eggs, I get 500 pancakes. If I have 3 eggs, I have 3 times 15, which is 15 pancakes, or 3 times 5, which is 15 pancakes. So we're going to now use the pattern to complete the table. And the pattern is the number of eggs times 5 equals the number of pancakes. Alright, so let's fill this table in together, guys. 3 times 5 is
15.
4 times 5?
20.
5 times 5?
25.
So that's how you complete your table. Is you just basically, once you establish what the unit rate is, that's your rule, and you follow that rule to fill in the rest of the table. But the key to filling in a ratio table is always you have to figure out what is the unit rate. Sometimes we want to skip that step, but you're going to have a very hard time filling in the rest of the table. So always get it down to 1 unit. Okay, so now that we have this beautiful chart completed, we're going to take and use this to fill in to plot these ordered pairs to see if we see a pattern there. To do this, how we graph it is we're going to make an X and Y axis. To do that, I have my vertical line, and I'm not doing a coordinate grid, I'm just doing 1 quadrant of the coordinate grid. Remembering that this is my X, this is my Y. I'm going to label X is going to be my eggs, and Y is going to be my pancakes. So this is my pancakes. This is my eggs. Going up to my chart up above, I'm either going to write it up here. Here's my X. Here's my Y. Now remember, when we do ordered pairs, it's X, comma, Y. The next thing we're going to do is we're going to number our axis. Now, here's where it gets interesting. So the first one with eggs, I'm just going to do 1, 2, 3, 4, 5. But if you look at the pancakes, we're actually counting by 5s. 5, 10, 15, 20. And I could write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I look at my pattern and they're all in stations of 5. So I'm going to make it easier for myself and I'm going to count by 5s instead. So I'm going to do 5, 10. And as long as you keep it evenly placed, it's fine to do this. It actually saves room. So 25. So now I've numbered my axes, and I'm now going to plot my ordered pairs. And remember, we do X, Y, and we always plot the X first. Let's scoot this up. Okay, so looking at our table, I went up too far. The first one, X is 1, Y is 5. It's going to look like this. 1, 5. So I'm going to go over to 1, up to 5, and I'm going to make a dot. The next one, 2, 10. Over to 2, up to 10, make a dot. Next one, over to 3, up to 15, make a dot. Over to 4, up to 20, over to 5, up to 25. And now I have put all of my ordered pairs onto my axes. Now, when we do this, we have 2 types of variables. We have the independent variable and we have the dependent variable. The easiest way to remember this is the dependent variable depends on the independent variable to change. So when we think of the eggs and pancakes, the more we increase our eggs, the more we increase our pancakes. The less eggs we have, the less pancakes. The more eggs we have, the more pancakes. So the amount of pancakes we have directly depends upon how many eggs. So our x values are going to be our independent variable. It's the variable that can change independent of everything else. Where our y value is the dependent variable. So this will be our pancakes, this will be our eggs. The other thing that's interesting about this, guys, and we're going to put a little note over here, is if your ratio is proportional, you will see a line on your graph. So let's see if we see a line here. You should see a diagonal line. Do we see a diagonal line?
Yes.
So it is proportional. Good. Okay, so we're going to do another practice on this. Now remember, if you need to, you can pause the notes or go back to the notes and go back to any information that you missed. But for the sake of time, we're going to go scoot over to page 59. And on page 59, we have another problem. And on this problem, it says for every 2 jumps, or 2 jumping jacks, like I meant to say, I burn 3 calories. How many calories will I burn if I do 20 jumping jacks? Fill in the table, answer the questions below, and graph it. Okay, so here we go. 2 jumping jacks, 3 calories. If I do 20 jumping jacks, how many calories will I burn? So our starting ratio is going to be 2 jumping jacks for 3 calories. So we can fill that first into our table. That's the first step. So we fill that in. Now we go to the next question. What is the constant rate of change or unit rate? So constant rate of change, that seems much more confusing. Basically, it's just we're getting down to 1 unit. In this case, the 1 unit is the jumping jacks. If I do 2 jumping jacks, I burn this many calories. Well, how many calories would I burn if I do 1 jumping jack? So to set that up, we're going to do a proportion. 2 jumping jacks equals 3 calories. What is jumping jack equals, we don't know how many calories. Let's look at our proportional relationship. 2 goes to 1 by dividing by 2. So 2 divided by 2 is 1. Well, what is 3 divided by 2?
1.5.
1.5, correct. So we know now that it would be 1.5 calories, or our unit rate would be 1 jumping jack equals 1.5 calories. So now that we know that unit rate, we can fill in using the pattern 1, or the number of jumping jacks, times 1.5 equals the number of calories. So let's fill in our table. 4 times 1.5, if I were to do that, I would end up with 6. So 4 times 1.5, you carry the 2, 6, count your decimals, you end up with 6. 10 times 1.5 is going to be 15, and 20 times 1.5 is going to be 30. It asks us, what is the dependent variable? Well, the dependent variable is the calories, and the independent variable is going to be the jumping jacks. The amount of jumping jacks I do directly affects how many calories I burn. I do more jumping jacks, I burn more calories. I do less jumping jacks, I burn less calories. Okay, and the final thing we're going to do is we're going to set up our graph. This is our y. This is our x. I'm going to count by 1, 2, 3. Sorry, this is smushed. 4, 5. I should have done that by 2s. We're going to change that. I didn't write it so great anyway. So we're going to do 2, 4, 6, 8, 10, 12. I should have gone further. 14, 16. Okay, that's good enough. Okay. And then we can count by 3s. That's not going to be. Let's count by 6s. 6, 12, 18, 24, 30. Okay, so we're going to have to kind of make it work. The first one is 2 and 3, so 2 is going to be about halfway, so it's going to be here. The next one, 4 and 6, go over to 4, up to 6, it's going to be here. The next one is 10, so we go all the way over here, 10 and 15, which, if I look at my graph, it's going to be right about here. And the next one is 20, which 18, 20, so it'll be here, 20 and 30, it's going to be about here. And we're going to see if we can draw a line, is it proportional? And we find out that yes, it is. And so this is the process that you use to take a ratio, complete it with the table, and then see if it is proportional, if you can create equivalent ratios with it. So once again, if you need any help or to go back, you can come to tutoring, or you can go back and re-watch these notes for more help. Thank you so much, and have a fantastic day.